So imagine you are looking at a system that is making some critical decisions based on some input parameters. Its decision has to be consistent whether you ask that question today, tomorrow, with the same input, it should give same output. Well, LLMs are not designed that way, right? They're probabilistic, right? They predict the next token, language models, right? And that is very important for anybody to understand.
Welcome to GenAI Talks.
Welcome, everybody. We're back having phenomenal conversations with brilliant minds. And today, we got something to talk about that might be the future now. So I have a phenomenal opportunity to be with these folks, but to bring this to you and really share with you some of the things, it's a dance. So anything you hear you like, let us know in the comments. If you're watching this video in the future, let us know. Can you introduce yourself to the audience? Let them know who you are and a little about your company, Flotorch.
Sure. So I'll thank you so much for the opportunity, Sam. And hey, nice talking to you guys. So my name is Hemant Joshi. I did my PhD very, very long time ago in 2007. Since then, I have been working for research companies, for startups, for Fortune 100 companies. I'm currently on the board and a CTO on Claim Genius, which is a automation claims company. We build their deep learning and AI vision models. But then what excites me most to be here today is my role at Flotorch. I'm Chief Technology Officer at Flotorch. And in that role, I get to define how the GenAI systems can be built by enterprises by still being compliant and at the same time make it easy for their developers and engineers to build it at scale.
What do people misunderstand about bringing these products to life that really you think would change the game if they knew?
Right. So the biggest challenge that I see kind of in terms of misunderstanding the field is some of the basics have not changed, but people seem to think that I can use a technology without knowing what the problem I'm trying to solve. Problem comes first, and then maybe technology, whether it is AI, ML, machine learning, or Gen AI, or something else, becomes part of the solution.
What are like just a range of things that are kind of being grappled with to do this well?
Yeah, let's look at a Gen AI life cycle within an organization. Okay, you're a big company, you're a CIO, CFO of a company, or you're a generative AI engineer, you're a data scientist who has done machine learning. Now you're looking into Gen AI. You could be a QA within an organization trying to make sure that the quality of what we build, a solution or a product, is better every single day before it goes out, right? So you could be any of these people, but the life cycle is such that you need to know what problem statement is being solved. And here is the challenge, right? According to Boston Consulting Group, they have published a research report of over 9,000 Gen AI professionals.
Deterministic systems versus undeterministic systems.
Yes.
Fundamentally, I think the world hasn't fully grappled with that difference yet. Because I see, to your point, QA is generally still treated the same, whether they're dealing with determinate or non-determinate. But for those that don't know, the way QA works is all about being able to recreate something. So if someone has a technical issue, if I can't recreate it, I can't technically fix it because I don't know where it's coming from. So being able to recreate something works when it's a deterministic flow. Can you share a little bit like just how that's done differently? Because what you kind of touched on, I think, is really brilliant, where by testing thousands of instances of what it does, you kind of approach the understanding of how well it's doing in a whole different way than you typically would in a deterministic systems. Can you just share a little bit about that? I think that's a fun one.
Deterministic systems are really important where if you ask the same question, it does not depend on amount of caffeine. That, by the way, usually me, if you ask me the same question, depending on how much caffeine I have had, I might give you a different answer. But the systems were predictable. So imagine you are looking at a system that is making some critical decisions based on some input parameters. Its decision has to be consistent whether you ask that question today, tomorrow, with the same input, it should give same output. Well, LLMs are not designed that way, right? They're probabilistic, right? They predict the next token, language models, right? And that is very important for anybody to understand.
If you have to take one area, you could put $1 billion into making the perfect life cycle.
Oh, okay.
What would that look like?
A lot of people are looking at different things. I'll give you one perfect example. Most of the LLM providers are claiming to have AGI. We, in fact, have a talk here and some people are talking about it. But average general intelligence is like having somebody who is jack of all trades but master of none. There are more domain-specific use cases that a previous speaker was talking about that I 100% identify with, right? We are in this room right now. Imagine that your LLM is full of this knowledge. Okay, it knows everything about everything in here. But what I really care about is, let's say, this camera and everything about it, right? then that's what the domain-specific knowledge means. And that's what the LLM needs to focus on. One of the biggest challenges that I see is people trying to think that by getting a large language model, it actually will do something better because it knows everything about everything at high level. So now back to your question about billions of dollars, I would be betting on two things. Okay, one is getting smaller language models to do a better job because they hallucinate less, they will use less energy, they will be actually more deterministic to great extent because it has lesser probabilities to work with. That's my one bet I really am looking forward to. The second thing that I'm really looking forward to is self-correcting agents. What's happening is right now we are defining, so, okay, you need these 3-4 agents in your agentic workflow. What if you can actually dynamically create these agentic workflows depending on the problem statement? You want to do a certain task, let's say booking a trip to Japan for 8 days in September. You figure out all the agents that you have available at your disposal. You figure out a plan on how to do it, and then you request those agents to perform along with their MCP and tools.
How can people stay in tune with Flotorch?
Oh, well, the two ways to do it very easily. Flotorch.ai, very easy to remember. It is flotorch.ai. It is a one place where you can try things out. You can see some of the articles. We have done comparative benchmarks across LLM providers, across agentic workflow engines. And we publish these as a matter of community contribution. And then the second place would be LinkedIn. Look us up on LinkedIn for Flotorch.
With that said, thank you. Amazing session today.
Big ideas, real tools, bold moves. That's what Gen AI Talks is all about. Don't miss what's next. Subscribe and explore more in our Gen AI community.